everyone, today we're going to take a look at the IXL that was assigned for week 6, lesson 2. You can see our directions. We're asking us to simplify and express your answer using positive exponents. This is taking everything we've been learning about exponents and combining it into one. So you can see that our problem says j to the 5th power all over j to the 8th power times j to the 2nd power. When we are solving these, we want to first look at our numerator and solve any math that we can do in the numerator, and then look at the denominator and solve any math that we may be able to figure out in our denominator. So you can see that in our numerator up here, we don't have anything that we need to do. So we can go ahead and just rewrite that. That is going to stay j to the positive 5th. And this is all going to be over what is in our denominator. Well, let's take a look. We have j to the 8th times j to the 2nd. Because we are multiplying those like bases, it means we can add our exponents. So in our denominator, we have j to the 8th plus 2. When solving this, we still have j to the 5th up here. And we now have j to the 8 plus 2, which is j to the 10th power. This now looks like the quotient property of exponents. Because we are dividing like bases, we can go ahead and subtract our exponents. This is all going to equal j to the 5 minus 10. And if we solve that, we get j 5 minus 10 is negative 5. This is where we need to remember that we cannot have negative exponents. Negative exponents do not like where they're at. They move to the opposite side of the fraction bar and they become positive. So this j to the negative 5 on the top of our fraction bar is going to turn into a j to the positive 5 below our fraction bar. And we're going to put a 1 there as a placeholder. So we can see that our final answer is going to be 1 over j to the positive 5th. Then we can see ones like this, where there is no fraction bar. All this is using the product property of exponents, where we are multiplying like bases. When we multiply like bases, all we need to do is add our exponents. So this whole problem here is going to turn into a to the negative 5 plus negative 8 plus 7. You can see that all I'm doing is adding my exponents. When we go ahead and solve this one, if you have negative 5 minus 8, you're going to get a larger negative number, and your answer is going to be negative 13. Then I have to bring down this plus 7. Negative 13 plus 7 is going to give us a negative 6. And we just need to remember that our base is a, and now all of this is raised to a negative 6. Negative exponents do not like where they're at. They move to the opposite side of a fraction bar and they become positive. So what's going to happen with this one is that a to the negative 6 is going to move to the bottom of my fraction bar, and it's going to become a to the positive 6. all under the number 1. So we'll put our fraction 1 over a to the 6th power. Now you can see where we have q to the negative 9th times q to the 3rd all over q to the negative 3rd. When working on this one, I'm going to start with my numerator. I have q to the negative 9 times q to the negative 3. Because my bases are the same, I can add those exponents. So what I have on the top of my fraction bar in the numerator is q to the negative 9 plus 3. And all of that is over q to the negative 3. I'm going to go ahead and keep working on the numerator. Negative 9 plus 3 is going to turn into q to the negative 6. And all of this is over q to the negative 3. This is now a quotient property of exponents. I am dividing like bases, which means I need to subtract my exponents. On a problem like this, it is very important that you do not drop your negatives, because what this problem is actually saying is what is q to the negative 6 minus negative 3. And what happens with this double negative is it becomes a positive. And negative 6 plus 3 is negative 3. So now I finally have one term, q, raised to an exponent, which is negative 3. But we cannot have negative exponents. Our directions even say positive exponents only. And negative exponents do not like where they're at. They move to the opposite side of our fraction bar and they become positive. So that negative 3 is going to move down here and become q to the positive 3. And we put 1 as a placeholder. So we can see that our final answer is going to be 1 over q to the positive 3. I'm going to jump ahead to a couple of the more challenging ones that might have been throwing people off. The larger numbers get a little bit more challenging, but do not be scared of them. You can use your calculator for these. A lot of questions revolve on some of these really challenging ones that we get to when you have a SMART score above 70. For this IXL, do not worry about getting an 80. We're really just looking for that 65 or 70 because we haven't quite learned this, and it's not super important that you can do this yet. We will get there, but it's not our focus now. But a couple of you do want to be able to do those, so we're going to kind of look at it. With exponents, all of this involves like bases, meaning that A and A are a like base, B and B are a like base, and C are a like base. But A, B, and C are very different letters. Those are not like bases. So when we have A to the 4th power times B to the 0th power times C to the negative 1st, we cannot do anything with those exponents. But on the bottom here, we have A to the 1st power and we have A to the 0th power, which we can symbolize as A to the 1 plus 0. And we have B to the negative 8th and b to the 0th power, which we can symbolize as b to the negative 8 plus 0. And we have c to the 9th power times c cubed, which I can extend this, and we symbolize as c to the 9 plus 3. I'm going to go ahead at this point and color code my letters. I have a to the 4th, b to the 0th power, and c to the negative 1. And all of this is over a to the 1 plus 0 is a to the 1st power. B to the negative 8 plus 0 is b to the negative 8. And c to the 9 plus 3 is really c to the 12th power. Now at this point, we need to remember a lot of different properties of exponents. Anything to the 0th power is the number 1. And negative exponents don't like where they're at. They have to move to the opposite side of the fraction bar and become positive. So for now, let's go ahead and just work with the negatives where they're at in place. This means I'm going to keep my a's exactly where they are for now, where I have a to the 4th over a to the 1st. We'll deal with that later. This b to the negative 8th doesn't like where it's at. We cannot have negative exponents. It moves to the opposite side of the fraction bar and becomes positive. So in this case, we're moving it up here, b to the positive 8th. I did not forget about this 0. Remember, anything to the 0th power is 1, and at that point, we can really just get rid of it. Now, the c to the negative 1st didn't like where it's at. It's a negative exponent. We cannot have negative exponents. It moves to the bottom side of the fraction bar. It becomes positive. So we now have c to the 1 plus 12. Because that negative 1 came down here and became positive. But we need to remember that we already had c to the 12th here. A to the 4th power b to the 8th power a to the 1st power, and when we add 1 plus 12, we get c to the 13th power. So now you can see that we only have one b term, we only have one c term, but we still have these two a's, so we're not fully simplified yet. This right here becomes a quotient property of exponents, where we have to subtract those exponents. It's going to become a to the 4 minus 1, and 4 minus 1 is 3, a to the 3rd power, or a cubed. All of that is above the fraction bar, so our very final answer is going to be a cubed times b to the 8th power, all over c to the 13th power. We're going to type it in and see if we did this all correctly. a cubed b to the 8th all over c to the 13th. So like I said, when we get to the SMART score of about 65 or 70, you do not need to worry about doing these problems. These are advanced. I do not expect you to know how to do these yet, but if you're up for a challenge, this is how you would get there. Just make sure that you keep your like terms together and do not combine your unlike terms.